this will be A dot A, then A dot B, again A dot B, and B dot B. Because A dot A can be expressed as this, B dot B can be expressed as this, A dot B square can be expressed by this and this. So this is how we calculate this is called the Lagrange's identity, that A cross B whole square is A dot A, A dot B, A dot B, B dot B. Fine. So this is something. Then we have scalar triple product. So let me shift it. Triple product. Scalar triple product. The scalar triple product of three vectors, let's say A vector, B vector and C vector, is defined as A cross B and that vector dot C vector. Now this will be a scalar quantity because this is vector, dot vector is a scalar vector. So scalar vector, that is A vector, B vector, C vector, sin theta and cos phi, where phi is the angle between, theta is the angle between A and B, phi is the angle between C and A cross B. Fine. C vector and A cross B vector, A vector cross B vector. So this is scalar triple product. You have to just calculate the magnitude, multiply it with sin theta and cos phi. You will get the scalar triple product of A, B and C. Now volume of a tetrahedron is given by volume of a tetrahedron. Tetrahedron is like this. Okay, so it is made by the vectors A vector, B vector and C vector. So volume is given by A cross B dot C vector. It is also written as A vector, B vector, C vector in the boxes. So this implies this. These two are equivalent. Okay. So next point, in a scalar triple product, the definition, the position of dot and cross matters. Okay. This it does not matter. It can be interchanged. So the definition, in a scalar triple product, the position of dot and cross can be interchanged. Remember this because this is used extensively in case of JEE exams. So A vector dot B cross C vector is always equals to A vector cross B vector and dot C vector. We have interchanged the position of cross and dot. Okay. Now this implies one more thing we can assure from this is that A, B, C, this will be equals to B, C, A, which will be equals to C, A, B. Of course the order matters because if you interchange these two then it will be a negative sign. Okay. So let me tell you that A dot B cross C is equals to minus A dot C cross B. Fine, because we have interchanged the positions of two vectors, not the sign between them. So ABC is minus ACB. Fine. Now if you have two vectors, let's say A vector as A1 I cap plus A2 J cap plus A3 K cap, and let's say B vector as B1 B2 B3 I cap, then I cap, then you have J cap, then you have K cap B3. So, and also you have C vector C1 I cap plus C2 J cap plus C3 K cap. Okay, you have three vectors A1, A, B and C vectors. Then how is this defined? This can be written as A1, A2, A3, as this is scalar, so it will be a scalar quantity C1, C2, C3. You have to just find the determinant of these coefficients A1, A2, A3, B1, B2, B3 and C1, C2, C3. This is much simpler. In general, let me have one more. Okay, so in general we have let's say A vector is A1 L vector. You can be given L vector, which is the sum of which can be expressed as A1, A2, A3, I cap, J cap, K cap, plus A2 M vector plus A3 N vector. Similarly, B vector is B1 L vector plus B2 M vector plus B3 N vector, and C vector can be represented as C1 L vector, C2 M vector, C3 N vector. Then this ABC will be, that is the dot product of the scalar triple product of ABC will be again the same, A1, A2, A3, B1, B2, B3, C1, C2, C3. This is the transpose I have written. You can write the another one which I wrote earlier. Doesn't make a difference. L vector, M vector, N vector. This can be represented as this. Okay, so this is the equality, and these are non-coplanar. These does not lie in a plane, because in that case it will be 0. Fine. So the next point from this can be derived as, if you have three vectors A vector, B vector and C vector which are coplanar, then this double implies that A, B, C, the scalar triple product of these three will be 0, because A cross B dot C. So A cross B will be in this plane and C is also in this plane, as they are coplanar. So that dot product will be 0, because theta is equals to 90 and cos theta will be 0. So that will make this expression 0. Now the next point about vector is volume of tetrahedron OABC. Let's say volume of tetrahedron OABC with O as the origin. Let's make it, this is our O, A, B, C. So OABC with O as the origin, okay, at 0, 0, 0, and ABC as vectors A vector, B vector, C vector. Fine. The volume of this tetrahedron is given by 1 by 6 A, B, C. Fine. This is the scalar triple product, and 1 by 6 of that will be volume of tetrahedron. In JEE 2 years earlier, it was asked that volume of tetrahedron directly, and A vector, B vector, C vector were given. So you have to just, and the origin was also given. So you have to just calculate this value and the determinant, value of that determinant. Okay, now the position vector, again for this, the position vector of the centroid of a tetrahedron. Centroid will lie somewhere here in this space, in between this tetrahedron. This is a 3D structure. Okay, you have to imagine this in between, in the center. Okay, from this line to this centroid of this triangle, from this point to centroid of this triangle, from this point to centroid of this triangle, all of them will meet at a single point, and that will be the centroid G. So the position vector of the centroid of a tetrahedron, fine, it will be, for this A, B, C, D vectors, it will be A plus B plus C, A vector plus B vector plus C vector plus D vector by 4. This will be the position vector of centroid of a tetrahedron with points A vector, B vector, C vector and D vector. These are the position vectors of the vertices of this tetrahedron. So the position vector of the centroid will be this. Fine. We'll move on to the next point, which is the vector triple product. So the vector scalar triple product is important, much important than vector triple product. Vector triple product is something like this: A cross B cross C. Of course, the direction will matter, so it will also be a negative sign if you interchange something A, B, and C also. So it is given by A dot C. First you dot this with this into B vector, okay, minus, this is a scalar quantity, so into B vector, not any dot product or scalar product. Then minus this with this, A vector dot B vector and C vector. Okay, this is called the vector triple product. And A cross B cross C, this will be different in this case. You cannot even change the brackets. This will be the same. Okay, if you change the brackets, this will be the same. So A dot C, again you go for this, and then this B vector minus A dot B minus B dot C, I'm sorry, or you can write C dot B vector A vector. Fine, so this is for, if you change the bracket, this term will change. It will be in the form of B vector and A vector. Fine. So in this case, A vector cross B vector cross C vector is not equals to A vector cross B vector cross C vector if the brackets are changed. So this was about the vector triple product. Then we have the reciprocal system of vectors. Okay, reciprocal system of vectors. This tells us that if A, B and C are three vectors and A dash, B dash and C dash are three vectors which are sets of non-coplanar vectors. Let's say we have A, B, C, A dash, B dash, C dash. These vectors which are non-coplanar, right? Set of non-coplanar vectors. Okay. Then, and if you are given the condition that A dot A dash is equals to B dot B dash is equals to C dot C dash is equals to 1. If you are given this condition, then the two systems are called the reciprocal system of vectors. If this condition, they follow this condition, then they are called the reciprocal system of vectors. These three and these three vectors. And A dash can be given by, in here, A dash vector can be given by B cross C vector, B vector cross C vector upon the scalar triple product. Fine. B dash will be given by C cross A vector divided by the scalar product A, B, C. Fine. And C dash vector will be given by A cross B divided by the same scalar product. Fine. So here we complete our vector algebra.